We will now discuss the case of a projectile at an angle. Now, in the previous lesson, in the previous part of this lesson, we talked about a projectile that is projected with a horizontal velocity, the case of a horizontal projectile. The more general case of a projectile motion occurs when the projectile is fired at an angle theta with the horizontal. Now that is very common around us. Now watch this illustration here. A golfer is hitting a ball, and look at this. The golfer hits the ball with a velocity v0. v0 is the velocity that is imparted to the ball the moment it is hit. And now that v0 is at an angle theta with the horizontal. And what happens? The ball rises to a height, at the same time moves horizontally. You can see it has an x motion and a y motion. Alright. If v0 is the velocity vector of the golf ball, can you tell me what are the components of this vector along the x-axis and along the y-axis? What is the component of v0? The angle it makes with the x-axis is theta. You know from our discussion on vectors, if a vector v makes an angle theta with the positive x-axis, its x component will be v times cos theta and its y component will be v times sine theta. So the x component of the velocity will be v0 times cosine of the angle theta, and the y component will be v0 times sine of the angle theta. You see, the horizontal motion is due to the horizontal component of velocity. The v0 cos theta is responsible for the horizontal motion, and v0 sine theta is responsible for the vertical motion. Alright, let's spend a couple of minutes talking about these velocities. Tell me, the component of v0 along the horizontal, along the x-axis, is v0 cos theta. Tell me, what happens to that velocity with time? Because there is no force in the x direction, the x component of the velocity will not change. v0 cos theta will remain a constant. Now look at the different positions of the golf ball. The horizontal velocity will not change. The horizontal velocity will remain a constant. But what happens to the vertical velocity, v0 sine theta? The vertical velocity will decrease, will become smaller and smaller until at the highest point the vertical velocity is 0. And then on, the vertical velocity increases in the negative direction. Right? Okay, so these two concepts are very important for us. Now, the time taken by the projectile to return to the ground is called the time of flight. So the golf ball is hit from this point, it rises to a maximum height and then falls back to the ground here. The time taken to do that is called the time of flight. And the horizontal distance traveled during that time of flight is called the range of the projectile. So range of the projectile is this horizontal distance it traveled during that time of flight. So some of these terms are very important for us. Now, when Tiger Woods hits a par 5, Well, the first ball, he wants to take it as far away as possible. The range has to be a maximum, as much as possible. Is that right? We will talk about that as we move on. Now, let us consider the case of a ball that is projected at an angle theta with the horizontal with a velocity v0. Alright, there is the velocity v0 at an angle theta. Now, v0 has a component vx0. What does vx0 stands for? Vx is the x velocity. Vx0 is the initial x velocity. So, this v0 has a component vx0 equal to v0 cos theta along the x-axis. This is v0 cos theta. And vy0, what does vy0 stands for? Initial vertical velocity. vy0 is v0 sine theta. I'm sure you have no problem understanding that. Now, vx0 remains a constant. This velocity will not change because there is no force in the x direction. Therefore, you cannot have an acceleration. The x velocity v0 cos theta remains a constant. vy0 decreases, reaches 0 at the highest point of its path, and then increases in the negative direction because of the gravitational force on it. Is that right? Okay. Now, this is the example again that we have talked about. The velocity of projection is v0. The component of that velocity in the horizontal direction is v0 cos theta, where theta is the angle of projection. And the component, the vertical component of that velocity is v0 sine theta. At any given time, the ball has a horizontal displacement and a vertical displacement. You see, because it has a horizontal velocity, it will move horizontally, and because it has a vertical velocity, it will move vertically. That means the ball has a horizontal displacement and a vertical displacement simultaneously. That means if you now look at the ball, say here, what is the horizontal displacement of the ball now? The horizontal displacement is this distance. What is that equal to? Because the horizontal velocity does not change, vx0 is a constant. So that horizontal displacement will be x equal to vx0 multiplied by time t, and vx0 is v0 cos theta. So x equal to v0 cos theta times t. That will be the x position. Now this x position is vx0 multiplied by time. And this is the y position. Now how will we obtain the y position? What is the equation for the y position? Y equal to vy0t minus 1/2 gt squared. Now here we assume that the ball was hit from the origin so that y0 equal to 0. Is that right? So y position is vy0 minus 1/2 gt squared, because its acceleration is always directed downwards. What is the value of vy0? vy0 is v0 sine theta. So the y position is v0 sine theta t minus 1/2 gt squared. And this is that y position. That means at any given time, the projected ball has an x displacement given by x equal to vx0 times t, which is v0 cos theta times t, and a y displacement given by y equal to v0 sine theta t minus 1/2 gt squared. Now look at this animation of a projectile at an angle. A ball projected with a velocity v0 at an angle theta with the horizontal from a height y0. This time the ball is not projected from the origin. The ball is projected from a height y0. Alright? So let's have a look at this. This is our y0. So can you now write the y position? What will be the y position? The y position now will be y of t equal to y0 plus vy0t minus 1/2 gt squared, and that will be y of t equal to y0 plus v/0 is v0 sine theta t minus 1/2 gt squared, and this will be the position function because the projection is now done from an initial height y0. Okay, now watch what happens. I want you to watch the animation. What happens to the horizontal velocity? The horizontal velocity does not change. Look at the arrow there. It remains a constant. And look at the vertical velocity. The vertical velocity decreases to 0 and then increases in the negative direction. Alright? And you can actually follow with time how the y velocity changes. The x velocity does not change, but the y velocity will keep on changing. Alright? We can now combine the x position and the y position and write a position function for the projectile. What is the position function? It will be xi plus yj. Alright, before writing down, can we think now mentally, what is the x position of a projectile? X position is vx0 multiplied by time, which is v0 sine v0 cos theta multiplied by t. And what is the y position? The y position is, if y0 is 0, it will be vy0t minus 1/2 gt squared. Let's write it down now. Alright? If the ball is at any particular position, it has an x displacement and a y displacement. So if the velocity of the ball at any given time is v, it has an x component, vx equal to v0 cos theta, and vy, what will be the velocity here? You see, the x velocity will not change. The x velocity when you hit it is v0 cos theta, and at any other time the x velocity will not change. But the y velocity will change. Look at the equation for the y velocity. We have vy equal to vy0 minus gt. Is that right? I think it has gone out of the screen. Let me write it here. Vy equal to vy0 minus gt. Now this is the equation that gives you how the y velocity changes. Now vy0 is v0 sine theta. So the y velocity will be vy equal to v0 sine theta minus gt. Now tell me, as this object reaches the maximum height, what is the value of Vy? That will be 0. In other words, V0 sine theta minus GT will be 0. Now, if you notice, if you set this V0 sine theta minus GT equal to 0 and solve for that t, what will that t be? It will be the time taken for the projectile to reach the maximum height. Yes. Okay, let's move on. So, at any instant, the projectile has a velocity along the x direction and a velocity along the y direction. So we can write V equal to Vxi plus Vyj. And what is Vx? Vx is V0 cos theta. And Vy is V0 sine theta minus GT. Alright? And what will be its x position? Its x position will be x equal to Vx0 multiplied by the time, which is V0 cos theta multiplied by time. And what is the y position? Do you remember the equation for the y position we obtained? It will be Vy0 minus 1/2 GT squared, where Vy0 is V0 sine theta. So that will be y equal to Vy0t minus 1/2 GT squared. That will be V0 sine theta t minus 1/2 GT squared. Alright, can you now write the position function for that projected object? This is the velocity function. Vector, this is the vector equation for the velocity. V equal to Vxi plus Vyj, where Vx is V0 cos theta and Vy at any given time will be V0 sine theta minus GT. Alright, can you write the position function? This is the x position and this is the y position. So we will write the position function as r of t. Now the position is not x, not y, so we will use the letter r to represent the position. R of t equal to the x position, Vx cos theta times t. That will be V0 cos theta times t. Is that right? Let's change that V sub x to V0. So the x position will be V0 cos theta times t. This is the x position. And the y position is V0 sine theta t minus 1/2 GT squared. And so the position function is V0 cos theta ti plus V0 sine theta t minus 1/2 GT squared j. Once you know the position function, you see, it will help you to solve any type of problem in projectile motion. You must understand the meaning of this projectile motion. Now let me ask you here, what is the value of, this is the y position, is that right? Yes. What is the value of that y position when the projectile returns to the ground? You project it from a point and it goes, reaches the maximum height and returns to the same horizontal level. What is the value of y when that happens? Y will be 0. So, when this quantity is 0, what can you say about this time? In other words, the time taken for the y displacement to become 0. What can you say about that time? The time taken for the y displacement to be equal to 0 is called the time of flight. We talked about the time of flight in the beginning. So the time of flight is the time taken for the y displacement to become 0. So if I want to obtain an equation for the time of flight, all I need to do is take this y position, set it equal to 0 and solve for t. We will do that in about 5 minutes from now. And tell me, I want you to think now. If I want to obtain an equation for the horizontal range, how will we do that? What is the horizontal range? The horizontal distance traveled by the projectile. Well, remember, x equal to Vx0 times t, V0 cos theta multiplied by t. When this t is the time of flight, then this x will be the range of the projectile. Is that right? When this t is the time of flight, the projectile has come back to the same horizontal level. It has covered this horizontal distance given by V0 cos theta multiplied by t. This t is now the time of flight. Okay, so once you know this equation and this equation, you can solve any projectile problem. All right, let's move on. Now, let me see if I can take you to a website. Now, again, let me acknowledge that all the animations and illustrations that I take from the web are not mine. I would like to acknowledge the hard work of those people. Now, here we have a very good animation to study horizontal as well as projectiles at an angle. We have a gun here, and the height of the gun can be changed by using this slider. The slider can be moved up and down to change the height. You can project it from the origin so that y0 equal to 0, or make y0 any desired value. And you can change the angle of projection by using this rotary kind of a switch. Alright? And you can measure the range, you can measure the time of flight. The time of flight will be measured. Alright, let's first of all look at the case of a horizontal projectile where the angle is 0. Alright, now the angle is 0. Let's run it. There you are. Now you can see the projectile was projected horizontally. It moved horizontally as well as vertically, and the horizontal distance traveled is, now what is the distance traveled? It is given here, 122 meters, and the time taken is 3.91 seconds. Alright, let me ask you. I want you to answer this question. It traveled a horizontal distance 122 meters in 3.91 seconds. What is the velocity of projection? Did you get the answer? Well, since the velocity of projection is a constant, you can get the velocity of projection multiplied by the time will give you the x value. Is that right? So x divided by time will give you the velocity of projection. Okay, now let me raise it and fire it again and see whether you get the same velocity of projection. Okay, I'm going to increase. All right. I'm going to use the sliding control to raise the gun to say 100 meters, that is y0, and let's fire it now. Alright. Now the horizontal distance now equal to 140 meter and the time taken is 4.49 seconds. Now, is the firing velocity the same as before? I want to calculate that. What is the velocity of launching? What is the horizontal velocity? Which will be 140 divided by 4.49. Alright, let's experiment some angle projection. Well, let's reset it and change the angle. Let's say the angle is 20, well, let's make it 25 degrees. There you are. The angle of projection is 25 degrees. So, what do we have? We have a projectile projected from a height y0 equal to 100 meter at an angle of 25 degrees, and you have calculated the velocity of projection. Have you? I'll give you two values to calculate the horizontal velocity. I hope you have calculated and that value is with you. You know the velocity of projection, right? The velocity of projection is that 140 divided by, is that right? Now, if V0 is that velocity, it will have an x component V0 cos 25 degrees and a y component V0 sine 25 degrees. Is that right? Let's fire it. There you are. And now, this is the time of flight, 6.04 seconds. Now, the time of flight is the time taken for the y position to become 0. And during that time, it traveled a distance x equal to 171 meter. So, you can see this 171 is V0 cos 25 times 6.04. You can do a lot of studies on this. Now, let's take it all the way down to the origin. Alright? All the way down to the origin. Now, in the meantime, I would also like to say this program is copyrighted to David Harrison. Alright? Now, we have the projectile, the gun at the origin, and I'm going to increase the angle of projection to, say, 42 degrees. Let's fire it. Here you are. Well, the horizontal range is 101 meter and the time of flight is 4.37 seconds. Well, and you know the velocity of projection. I hope you calculated. If you haven't, I want you to rewind and go back and look at the first values. Calculate the velocity of projection. This gun always fires with the same velocity. Okay, let's move on. I'm going to leave it for you. You can go to this website that I have given to you in the PowerPoint and play with it. This is a very, very nice animation. Okay, let's move on. Let's now obtain an equation for the time of flight. Now, how did we say we are going to obtain the equation of the time of flight? Time of flight is the time taken for the vertical position to become 0. Therefore, we start by looking at the position function. R of t is Vx cos theta ti plus V0 sine theta t minus 1/2 gt squared j. this is the x position of the projectile, this is the y position of the projectile. Now, during the time of flight is the time taken for the y position to become 0. And so, what do? We take the y position, set it equal to 0 and solve for the time. So y equal to v0 sine theta t minus 1/2 gt squared. Can you solve for t from here by setting y equal to 0? So 0 equal to v0 sine theta t minus 1/2 gt squared, and I solved it for you. Well, factor out a t. That means one value of t will be 0. Why? That is the time when the projectile begins. And the other time will be the time of flight, which will be 2v0 sine theta divided by g. Now this is an important equation. This is called the time of flight equation. The time of flight of a projectile is t equal to 2v0 sine theta divided by g. Let's now obtain an equation for the horizontal range. Well, this is the time of flight, t equal to 2v0 sine theta divided by g. And we had discussed this earlier. Horizontal range is the horizontal distance covered by the projectile during this time, and the horizontal distance x equal to the horizontal velocity multiplied by the time, isn't it? Okay, so horizontal range is the x displacement during this time. Therefore, range is vx0 multiplied by the time of flight. What is vx0? Well, vx0 or vx, since vx does not change, it doesn't really matter. And what is that equal to? That will be v0 cos theta. So this vx0 is v0 cos theta, and the time of flight is 2v0 sine theta over g. Alright, simplify this. That will be v0 times v0 is v0 squared. So that will be 2v0 squared cos theta sine theta over g. Alright, let me ask you this. I don't think many of you will recall. What does 2 sine theta cos theta represent? Can you remember an identity that you probably learned in trigonometry? You have most certainly learned that in trigonometry. What is 2 sine theta cos theta equal to? Well, 2 sine theta cos theta equal to sine of 2 theta. Sine of 2 theta. So we can now replace this 2 sine theta cos theta by sine of 2 theta, and so the equation for the horizontal range of a projectile is range equal to v0 squared sine of 2 theta over g. Now, the question I want you to answer is, if this is the range, what angle of projection will give you the maximum range? Suppose you cannot increase the velocity of projection anymore. Suppose you want to give some tip to Tiger Woods in his golf, and he cannot increase on its technique or the amount of force he can apply. Means he cannot increase V0 any further. Now tell him what angle he must hit to get the maximum range on a par 5. Now here I have an animation of 3 angles of projection. Now the first one is 30 degrees, the next one is 45 degrees, and the last one is 60 degrees. Which of them gives you the maximum range? That's very obvious there, is that right? Well, obviously you can see 45 degrees gives you a better range. Now, why is it so? Let's look at the equation. The range x equal to v0 squared sine of 2 theta divided by g. Now, the range becomes maximum when sine of 2 theta over g is the maximum. Now, what is the maximum value of a sine function? You see, a sine function cannot exceed 1. Sine of 0 is 0, sine of 90 is 1, sine of 90 degrees, I'm not talking radians, sine of 90 degrees is 1, sine of 180 degrees is 0, is that right? So, this quantity will become maximum when sine of 2 theta becomes 1, because sine of a quantity cannot be greater than 1. And when will this sine of 2 theta become 1? When this angle 2 theta is 90 degrees. So this happens when sine of 2 theta equal to 1 or 2 theta equal to pi by 2, which is 90 degrees. And therefore theta for maximum range is pi by 4, which is 45 degrees, right? You got to fire a projectile at an angle of 45 degrees in order to produce the maximum range. I want you to look at this diagram, and I haven't given you any assignment for extra credit so far. Now this is an extra credit assignment. Now look at this. An angle of projection 75 degrees and an angle of projection 15 degrees give you the same horizontal range. An angle of projection 60 degrees and an angle of projection 30 degrees gives you the same horizontal range. And the maximum range occurs for 45 degrees. Now, the assignment is this, and I will give you 2 extra credit points for that. Alright, if you don't want it, you don't have to send it to me. But if you want it, write a good paragraph showing solid reasons why these 2 angles, 75 degrees and 50 degrees, gives you the same horizontal range, why 60 degrees and 30 degrees gives you the same horizontal range. Alright, show me the arguments using mathematical equations if you like. Alright, and that carries 2 extra credit points. Okay, now I want to ask you a question. Now the question is this. It's an old question actually. Here is a hunter. A hunter is hunting a monkey. This is the unfortunate monkey. Now, this is a tree branch. The monkey is hanging from that branch. Now, the hunter wants to shoot the monkey. Now, the question as physics students going to advise the hunter, do you really have to, what direction should the hunter really needs to shoot? Because this monkey is a very clever monkey. You know what the monkey is going to do? As soon as the hunter pulls the trigger, you know, he can see the fire. He's going to let go. That means he's going to drop. You see, the monkey says, I will teach you a lesson, hunter. So the moment the hunter pulls the trigger, the monkey lets go from the branch and falls. Now, the hunter knows that, because the hunter, this is not his first time. The hunter knows that the monkey is going to drop. So, in what direction should he aim the rifle? Now, at the moment it is aimed directly at the monkey. Now, will the bullet hit the monkey? What do you think? At the moment the gun is aimed directly at the monkey, and the moment the bullet is fired, the monkey is going to let go from the branch. Will the bullet hit the monkey, or will the hunter lose a bullet and lose the monkey? I'm sorry, I'm hurting some of the feelings that the hunter is hunting a monkey. Well, it's just figurative. Okay? Well, let me animate this and see where is the bullet going to go. Alright, watch it and explain this to me. Well, what happened? Watch it again. Did the bullet hit the monkey? The poor monkey would have been fortunate to stay there. Because the monkey dropped at the same time the bullet is fired, it got hit. Why? Because the moment the bullet comes out of the gun, it begins to fall freely. And the monkey decides to fall freely as well. That means the bullet and the monkey are falling at the same rate. So the bullet doesn't go straight at the monkey. The moment the bullet comes out, it falls like this. And the monkey also falls, and the bullet goes and catches the monkey. You see, that is the situation. Okay, let me also show quickly a couple of other animations that I have taken from open webs. The same argument can be found in this example, which I have borrowed from the open web, the zookeeper's dilemma. Now, this is the same example. You see, a lot of people don't like to fire bullets at monkey, but they would like to throw a banana at the monkey. You see, rather than shooting a monkey, you feed a monkey. Now, here is the zookeeper's dilemma. A monkey is hanging from a tree branch, and the zookeeper shoots a banana at the monkey. Now, the problem is, unfortunately, the monkey lets go of the branch the moment the banana is fired. The zookeeper is faced with the dilemma where to aim the cannon. Well, now you know, you can advise the zookeeper. Is that right? Now, should he aim above the monkey, below the monkey, or directly at the monkey? As soon as he shoots the banana, the monkey is going to let go. Alright, there the zookeeper made a mistake. He aimed the banana above the monkey. So what happened? Poor monkey did not get it. Alright. Now, what happens if the zookeeper aims the banana directly at the monkey? Well, this time it is aimed directly at the monkey, and you can see the monkey really caught it. Why? Again, the same question. The moment the banana is fired, the banana is falling freely, and if the monkey also begins to fall freely, the banana will meet the monkey. There you are. Now, what happens if the zookeeper fires the banana at a slow speed? Will the monkey still get the banana? Alright, let's have a look. There you are. The speed is slow now, but still you can see, as long as it is aimed directly at the monkey will still get the banana, because the banana and the monkey are falling at the same rate. So you need to aim it directly at the monkey. Now, you notice, if anybody has experience in using a rifle to shoot a target, do you really aim the rifle directly at the target? Well, if you aim the rifle directly at the target, horizontally, you will not hit the target. Why? Because the moment the bullet comes out, it is dropping also. That means your rifle needs to be aimed at an angle so that the bullet comes out and then goes to the bullet. Alright? Okay. Now here is another example I want you to think about and talk about and write about. I would like to hear from you. Now, a ball is fired from the back of a truck that is moving forward with a uniform velocity v sub x. So, a truck is moving forward with a velocity. Now, this is what happens. Now, this is a truck. It is moving forward with a velocity vx. And somebody stands on the truck and fires a ball upward. And the truck goes away. Now, what will be the nature of motion of that ball? Can you think about it? All right. You see, physics is something that should make you think. If you cannot think, you cannot learn physics. All right, look at this animation. There's a truck, the ball is being fired. Well, what does that mean? Okay. Well, you've got another extra credit point for this. Write a paragraph. I don't just want one sentence. Write a paragraph about why this happens. Why does the ball fall back in the truck? The truck is going with uniform velocity. Alright? Why does the ball fall back in the truck? Write a paragraph about this and send it to me. It's worth 1 point. So this lesson has been particularly fortunate for you because you're going to earn 3 extra credit points and a lot of areas you can think. Is that right? Okay, in that case, I'm going to stop this part of the lesson here and I'm going to do another part where we will use all the formulae we developed in projectile motion to solve problems. Alright, I will see you for that part in a little while.